Welcome to Study Loop.
So we can say for part A, we're going to suppose we have a total of n transparent layers. In this case, we have n equals 5 transparent layers. We're going to label these layers from left to right with indices 1, 2, 3, 4, 5, up until n number of layers. So the indices simply to the layer. And so we can say that we're going to let the index of refraction of the air be n sub 0. So this would be air, the refractive index of the air. And we're going to denote the initial angle of incidence of the light ray upon the air layer boundary as, we'll say, theta sub I. So this would be the angle of incidence upon the air layer. And then we can say that the angle of the emerging light ray would be, so this would be incident ray, and we can say theta sub f would be emerging ray. And at this point, we can then say that since all the boundaries are parallel to one another, the angle of incidence I sub j, this would be the we can say angle of incident angle between the jth and the j plus 1th layer, essentially. So we can say that this is going to be the same as the angle between the transient ray and the norm in the jth layer again. So for the first boundary, we have n sub 1 divided by n naught would be the refractive index of air. So this would be sine of theta sub I divided by sine of theta sub 1. For the second boundary, this would be for the first. For the second, we have n sub 2 over n sub 1 equaling sine of theta sub 1 divided by sine of theta sub 2. And then finally, we have for the last boundary, n sub o divided by n sub n will equal sine of theta sub n divided by sine of theta sub f. So we're going to multiply these equations. Say that here n sub 1 over n naught times n sub 2 over n sub 1 times n sub 3 over n sub 2, and then so on, will be equal to, rather, up until essentially n naught to n to the n, this would be equal to sine of theta sub I sine of theta sub 1 times sine of theta sub 1 divided by sine of theta sub 2 up until, again, sine of theta sub n divided by sine of theta sub f final. Now we're going to see that the left-hand side of the equation above can be reduced to NO over NO. So essentially, while the right-hand side of the equation is equaling sine of I divided by sine of f. So essentially, we can say sine of theta sub f would be equal to n naught over n naught. This would be equal to sine of theta sub I equaling sine of theta sub I, given that these cancel out. So essentially, the incidence ray would be equal to the final angle. So for the case in the problem statement, say that the angle of the emerging light rays are both the same as their respective incident angles. This would be our answer essentially for part A. For part B, given that theta sub f equals 0 for ray A, we can say for part B, theta sub f equals 20 degrees for ray B. Oh, sorry, this would be, my apologies. This would be our for part A. This would be our answer for part C. And for part B, so for part C, however, all we need to do here is change the value of n not equaling 1.0 to n not equaling 1.5 for glass. So, but again, because in the initial part A, they both cancel out. So it doesn't really matter what the medium is. So essentially for part C, rather, theta sub f equals 0 for ray A once again. And for part D, we can say theta sub f equals 20 degrees for ray B. So that would be our final answer. We know that here it is the independent of the number of layers and the thickness of the layers and refractive index of each layer. It's only dependent on the effective incident angles. That is the end of the solution. Thank you for watching.